So right now, somewhere out in the Pacific, there is a massive storm system building up.
Yeah, a really serious one.
Right. And it's forcing a major shipping port to just completely halt operations. And, if you think back maybe 10 years ago, an event like that, I mean, that meant weeks of delayed shipping.
Oh, absolutely. Sudden factory shutdowns, massive backlogs.
Exactly. And eventually empty shelves at your local grocery store. But today, it's different. Today, there's this invisible digital brain that has already, calculated the storm's trajectory. It's analyzed port congestion in 3 different countries, and it's rerouted 1,000 cargo ships before the first drop of rain even hits the water.
And, the most remarkable part about all of that is that it did it entirely in the background. I mean,
Right.
Nobody panicked.
Right.
No one had to frantically redraw shipping lanes on a whiteboard in some war room. The system just absorbed the shock and adapted in real time.
That is exactly where we're starting today. Welcome to the deep dive. We are so glad you're joining us for this one.
Yeah, it's going to be a fascinating discussion.
It really is. We are unpacking a really incredible look at the current state of computation today. We're drawing from this excerpt from a YouTube video by Google, and it's titled "The Era of AI Innovation Where the Internet Lives."
It's a great piece of source material.
Totally. And the core mission for our deep dive today, the premise we're exploring, is this idea that society has basically, picked all the low-hanging fruit of human progress.
Right, the easy stuff is done.
Yeah, exactly. I mean, we figured out mass agriculture, we mapped the globe, we built combustion engines. So the problems we actually have left to solve, they aren't the simple ones anymore.
Not at all.
They're incredibly dense, highly tangled, civilization-scale hurdles. And we're going to explore how AI is stepping up to tackle these massive issues.
Because we're looking at systems now that have just grown so large and so interconnected that they've honestly surpassed the limits of human cognitive capacity to manage them. And the source material makes this really poignant philosophical point. The advances we are seeing in artificial intelligence today, they're often described as just the tip of the iceberg.
Just the tip. Wow.
Yeah. Because we're transitioning AI from this, novelty, like a fun little chatbot you play with, into a fundamental utility that's designed to manage all that overwhelming complexity we just talked about.
I think of it a lot like the transition from the steam engine to the electrical grid.
Oh, that's a good analogy.
Right. Because when electricity first arrived, it was basically a parlor trick.
Yeah.
People used it to light up a single bulb in a dark room, and everyone gasped.
Yeah, they had no idea what was coming.
Exactly. They couldn't fathom that the exact same unseen force would eventually, power life support machines in hospitals or global telecommunications or even modern refrigeration. AI is stepping into that exact same infrastructural role for our physical world right now. And the materials we're looking at, they really ground this whole rewiring process in the dirt, literally in the dirt.
They really do. They start right at the absolute baseline of human survival, which is agriculture.
Right, because we have to fix the physical systems keeping society running before we look at, anything else.
Exactly. And the agricultural system has obviously done this amazing job keeping a massive, globally distributed population alive.
Yeah.
But it has come at a cost.
A huge cost.
Yeah. We've optimized traditional farming to its absolute limit, extracting maximum yield. But the environmental and systemic toll is immense. The whole system is actually incredibly brittle right now.
So, okay, how does a digital algorithm actually fix dirt and seeds? The material points out that AI allows small producers to get faster access to new crop varieties that will actually work for the future climate.
Right.
But mechanically, how is a computer growing a better plant?
Well, it comes down to predictive genomics and environmental modeling.
Okay.
So think about the traditional method. You'd plant a new seed variation, you'd wait an entire growing season, months and months, and then you'd see if it actually resists a specific type of drought or pest.
Which is incredibly slow.
Exactly. But AI simulates that entire process. It models how millions of genetic variations will interact with really highly specific, localized climate variables over the next decade.
Wait, so instead of physically waiting for the sun and the rain to do their thing, the system is mathematically running 1,000 potential growing seasons in just a few hours of compute time.
Precisely. It isolates the most resilient genetic traits digitally way before a single physical seed ever goes into the ground.
That's wild.
And because that computation is relatively cheap compared to, a decade of failed physical crops, that predictive power can be handed directly to small-scale farmers.
Wow, so it democratizes it.
Exactly. It isn't just locked up entirely by these massive agricultural conglomerates anymore.
And that data-driven approach, it translates directly to what happens after the food is grown too, or after a product is manufactured.
The logistics side.
Right. If agriculture is about creating the resources, the global supply chain is about distributing them. And right now, modern supply chains are just staggering under their own weight. They're so inefficient.
They really are.
The material highlights this company called Dexery, and they're completely overhauling warehouse logistics using robotics and AI. And apparently, they are sitting on one of the largest databases of warehouse information in the world.
Yeah, and to understand why that matters, you have to consider what a warehouse actually is in the modern era.
Okay.
It's not just a static building where things sit gathering dust. It's a highly dynamic, hyper-complex node in this massive global network.
You know, I always used to picture the global supply chain like this unimaginably massive, incredibly messy closet.
That's exactly what it feels like.
Right, for decades, we've basically just been shoving boxes in there, closing the door, and hoping we can find what we need when the time comes.
Hoping for the best.
Yeah, but what Dexery is doing, it isn't just sending a faster robot into the messy closet to grab a box, right?
No, not at all. They're building a real-time digital twin of the entire physical space.
At a digital twin.
Yeah. So every single item, its exact dimensions, its weight, its expiration date, its exact coordinates on the shelf, and its eventual destination. All of that is constantly mapped and updated.
But I want to push back on this a little bit, actually. Are we just using AI to make a fundamentally broken system slightly faster? Because, I mean, making a bad system operate at a higher speed usually just means it crashes harder when it fails.
That's a very fair point.
Does having this granular data actually change the nature of how we distribute goods?
Well, that distinction is vital. It is not just about speed, it is entirely about resilience.
Resilience. Okay.
Right. A fast system can still be brittle, like you said, but a resilient system can take a punch. By synthesizing this massive ocean of global warehouse and transit data, AI allows the supply chain to actually anticipate bottlenecks.
Oh, I see.
It understands the downstream butterfly effect of a single delay. So if a factory in Taiwan suddenly shuts down, the system doesn't just wait for the shortage to hit Europe.
It's proactive.
Exactly.
Yeah.
It instantly recalculates inventory across thousands of global nodes and reroutes materials to absorb the shock before anyone even notices.
So it's the difference between reacting to a crisis and mathematically avoiding it altogether.
Perfectly said.
And, you know, if predicting these massive patterns can untangle the global supply chain, it makes total sense to turn that exact same pattern recognition power onto something much more intimate.
Shifting from the macro to the micro.
Right, because if fixing supply chains is about economic survival, fixing healthcare is about our literal physical survival.
Absolutely.
If an algorithm can track 1 million shipping containers in real time, what happens when it maps the millions of molecules in the human body?
Well, you move into incredibly profound territory. The material points out a very raw, universal reality.
Yeah, this part was heavy.
It really was. Almost everyone has experienced the profound sorrow of losing a loved one or a close friend to a disease that simply lacked a good treatment.
Yeah.
And there's this overriding feeling mentioned in the source that there just had to be a better way to find cures.
Because the tragedy of modern medicine hasn't necessarily been a lack of brilliant scientists. I mean, we have those. It's been the agonizingly slow physical bottleneck of the discovery process itself.
It's so tedious.
Right. Think about how we traditionally discover drugs. It's basically like searching for a specific grain of sand on a massive beach, or actually like trying to forge 1 million different keys by hand entirely through trial and error just to see which one happens to fit a specific lock.
Yeah.
You're sifting, you're testing, mixing chemicals in a lab, and failing over and over for years.
And that is exactly where the computational shift happens.
Yeah.
AI approaches this not through physical trial and error, but through advanced predictive mathematics. It acts like a hyper-focused metal detector, pulling the right molecules out instantly. Or to use your other analogy, like a master locksmith.
Right.
The AI models the complex three-dimensional shape of a disease's protein structure. That's the lock. Then it calculates the exact molecular shape the key needs to be to bind to it. It's effectively testing millions of chemical compounds digitally in seconds.
Wow. So it knows the shape of the key before anyone even touches a piece of physical material in a real lab.
Yes. It isolates the most viable candidates almost instantly. And the material emphasizes that using these powerful computational tools, is what might bring better medicines to patients faster and at a much lower cost.
That's incredible.
It really is. It dramatically shifts the way healthcare is delivered for all of us. In fact, one of the individuals in the video describes this specific application as representing one of the most important impacts that I can have on humanity.
And you can feel the emotional weight of that in the text. This isn't just about technological efficiency, you know? It's a complete paradigm shift in human care. The high cost and the slow speed of drug discovery have been this tragic bottleneck, and AI is basically breaking that dam open.
It's fundamentally changing the timeline of hope.
But, you know, practically speaking, if the AI is so good at predicting the shape of the key, why do new treatments still feel like they take forever to reach you and me?
Right.
If the bottleneck is broken, where is the flood of cures?
Well, because we're currently in what you could call the implementation lag.
Implementation lag.
Right. AI has shattered the discovery bottleneck.
Right.
It can find the right molecule on a Tuesday.
Okay.
But you still have to physically synthesize it in a lab, run the multi-year clinical trials to ensure it's actually safe in complex human biology, and navigate all the regulatory framework.
Oh, right. Because human biology is messy.
Exactly. The computation is instantaneous, but the physical validation still respects the speed of biology.
Right.
But the fundamental barrier, finding that needle in the chemical haystack that has been removed.
That makes a lot of sense. So we have these vast algorithms feeding the world, routing cargo ships around storms, designing life-saving molecules. It naturally raises a rather existential question.
It usually does.
Where does the individual human fit into this hyper-efficient future? I mean, when systems become that big and that capable, the individual can start to feel very small or even obsolete.
It's a very common anxiety right now.
Yeah.
But the source material frames this era of AI not as a replacement of the individual, but actually as an empowering tool.
Yeah.
It democratizes capability.
Yeah, they focus heavily on demography and creativity to make this point.
Exactly. They highlight Technovation, which is an organization with this mission to empower girls and young women globally to become technology leaders and innovators.
Right, which is so cool.
It is. It's a deliberate effort to ensure that the people directing these powerful tools represent the entire spectrum of human experience, not just, a narrow demographic.
And the material also dives into the creative side. There's this story they tell of a writer using a large language model, an LLM, for the very first time, and they describe getting completely hooked. The specific word they used was limitless. They felt limitless when it came to the stories they could imagine.
It's a powerful feeling.
It is, but I have to be honest, I struggle with that framing a little bit.
Why is that?
Well, because if a storyteller sits down, types a prompt into an AI, and the machine generates the plot, the pacing, the characters, and the dialogue. Oh, wait, sorry. I mean, it generates all of that. What is the actual role of the human?
You're asking where the art is.
Yeah. Are we just becoming the editors of an AI's imagination? If I just tweak a comma on a 500-word output, I didn't create that story. The algorithm did.
Well, you're assuming the output itself is the core of creation. But the material provides a very profound counterweight to that exact anxiety.
What's that?
There's a quote. Technology always disrupts society, but our creativity is the one constant.
But how does that hold up when the machine is the one doing the writing?
Because an AI has no intent. It has no lived experience.
Oh, I see.
It has never felt the grief of losing a loved one to a disease, which we just discussed. It hasn't felt joy or fear or ambition. A machine is just a mirror reflecting the patterns of human language.
Right.
It doesn't possess a soul to express. The human provides the spark, the specific emotional truth, and the intention.
So you're saying the AI merely removes the mechanical friction between the human imagination and the blank page?
Precisely. Whether it's young girls learning to lead via Technovation or a writer finding infinite inspiration, the AI democratizes power. It doesn't replace the storyteller. It gives them a lever long enough to move the world. Human creativity remains the anchor in a sea of disruption.
I love that. Human creativity remains the anchor while the machine handles the heavy lifting of the execution. But let's pull back the curtain on that machine for a moment.
Yeah.
We've spent this whole deep dive talking about the algorithm and the cloud and the AI as if they are these magical floating concepts.
Right up in the sky somewhere.
Yeah. But this magic does not live in the ether. It requires a massive physical engine.
It is a highly physical industrial reality.
And the video we're analyzing is literally subtitled, "Where the Internet Lives." And it's incredibly blunt about the physical demands of this revolution.
Oh, staggering complexity.
Processing global supply chains, rendering molecular structures, generating limitless narratives, it all requires a massive amount of computational power. The reality is summarized in one stark quote from the source. If we didn't have data centers, none of this would work.
Yeah. The next time you generate an image on your phone or you ask an AI to summarize an article for you, you aren't just doing math in the air.
Right.
You are physically pulling electricity and cooling water into a massive, highly secure building, humming with servers, likely sitting out in a desert somewhere.
I always think of data centers like the invisible plumbing of a modern metropolis.
Oh, that's perfect.
Because, nobody walking down the street thinks about the massive network of high-pressure pipes beneath their feet, not until they turn on the tap in their apartment.
Exactly. You just expect the water to flow.
Right. But those underground pipes are the literal foundation of the city. Without the plumbing, there is no city. Without data centers, there is no AI revolution.
And tying it back to where the internet lives, it really helps to visualize that the cloud isn't a floating concept. It exists in physical buildings. And data centers actually make the jobs of thousands of companies dramatically easier.
This was the detail that really stuck with me, actually. Even a tiny nonprofit like Technovation, operating on a fraction of a corporate budget, relies entirely on data centers to achieve its massive global impact.
Because the infrastructure is centralized, the access to that world-changing computational power becomes decentralized.
That's such a good way to put it.
That small team of educators trying to teach young girls how to code is plugging into the exact same computational plumbing as a multinational pharmaceutical giant searching for a cure for cancer.
They don't have to build their own supercomputer in a basement. They just rent a sliver of the global brain.
Exactly. The barrier to entry for solving the hardest problems in the world has effectively dropped to zero, as long as you have an internet connection and the creativity to ask the right questions.
Wow. We have covered immense ground today.
We really have.
We started by looking at how predictive models are pushing the boundaries of agriculture, right? Running thousands of digital growing seasons to find resilient crops before a single seed is even planted. We saw how creating digital twins of colossal warehouses allows global supply chains to absorb shocks and reroute materials instantly.
Moving from the logistics of the planet to the biology of the individual.
Right. We looked at how AI acts as a mathematical master locksmith, predicting the shapes of complex molecules to shatter the historical bottleneck of drug discovery and find life-saving medicines.
Yeah.
We debated the role of human intent in an age where machines can generate limitless stories, finding that our human creativity is the constant that directs the tool, empowering young female coders and unlocking human imagination.
It's all connected.
And finally, we anchored all of these civilization-scale shifts in the physical, quiet hum of the data centers that democratize this power for everyone.
It is the invisible engine of the next era.
So for you listening, the next time you track a delayed package that suddenly arrives on time, or read a captivating story, or hear about a miraculous medical breakthrough, remember what you are actually interacting with. You are witnessing the profound computational power of this new era, actively rewiring how our species solves its hardest problems.
And, if the advances we are seeing today truly are just the tip of the iceberg, it leaves us with a really profound thought to consider.
What's that?
We spent centuries using our human ingenuity just to secure the basics, to grow enough food, to move goods, to survive diseases.
Right, the low-hanging fruit.
Exactly. If this centralized computational power finally takes over the heavy lifting of our basic physical survival, our logistics, our agriculture, our medicine, what entirely new, currently unimaginable problems will human creativity choose to tackle once our hands are finally free from those burdens?
Man, that is a whole new landscape, something to really mull over. Thanks for diving deep with us.